Hello everybody, today we're looking at distance time graphs. This is an important topic in maths as well as physics. So, let's have a look at a distance time graph. It's a graph with time across the bottom and distance across the side. The x-axis is time, the y-axis is distance. Time can be measured in seconds, it can be measured in minutes, hours, and sometimes, like this, is written as actual times in the day. Distance can be measured in meters, kilometers, or any other measure of distance you can think of. Now we're going to draw a distance time graph for John's journey, and it says John set off on a road trip at 1:30 p.m. So he put a X here at 1:30 where he started. He started at 0 kilometers away, so at 1:30 he was 0 kilometers away. Then he drove 60 kilometers in 1 hour. So 1 hour later he is 60 kilometers away. And we connect that up with a straight line. Then he continues his journey. He stopped for lunch for 30 minutes. And so we draw a straight line where we stay at 60 kilometers across for 30 minutes. Continues his journey. He went 100 kilometers in 90 minutes. So you go from 60 up another 100 to 160 in 90 minutes. Notice that the scale on the bottom is going up in 30 minutes. So 30, 60, 90 gets us to here. He stayed at his friend's house for 1 hour. So he stayed at 160 kilometers away for 1 hour. And then he drove straight home, arriving at 7 p.m. Okay, that is our distance time graph. So distance time graphs are really helpful for describing how things move. And it can describe car journeys, walking, or any other motion you can think of. Now, we can understand parts of the graph by looking at the gradient. The gradient here tells us the velocity. So if it's pointing upwards, it means the person or the object is going forwards. If it's flat, like this, it means the object is at rest. That's another fancy word for meaning staying still. Not moving. So if it's flat, it's not moving. And then if the graph is going down, it means you're going backwards, you're going back to where you started from. So you can actually tell which direction people are going based on the gradient of the distance time graph. Now, we can find even more information by actually measuring the gradient. And that gives us the actual speed. The speed is given by the change in distance divided by the change in time. So, the change in time is 1.5 hours, and the change in distance is 100 kilometers. Putting those numbers in, 100 kilometers divided by 1.5 hours is 66.7 kilometers per hour. And notice the units are kilometers and hours, kilometers per hour. So when you're doing this in the exam, actually draw on how far you're going across and how far you're going up. And measure that carefully using your graph. This is a really important skill, measuring the gradient in maths, and it's also important in science as well. So it's well worth you getting some practice with this. Okay. Now, we can also understand that if a graph is curving upwards, that means the gradient is increasing, and so the velocity and the speed is increasing. And if the speed is increasing, that means that it's accelerating, it's getting quicker. So if you see a graph curving upwards, that means it is getting quicker, it is accelerating. That's a really common exam question where you have to describe what the curve means. Similarly, if it's curving downwards, then the gradient is decreasing, it's getting less steep. And that means the object is decelerating. Okay? That's everything you need to know about distance time graphs. So thank you for watching this video. And remember, we have more videos coming every week for everything in GCSE, A-Level and IB Maths. So remember to like and subscribe for more videos. Well, thanks for watching and good luck in your exams.